Heterolytic fission and types of carbocations. This is today's lesson. In this lesson, we are going to learn what is heterolytic fission and how many types of carbocations can be produced and how they are produced. So let us begin. Heterolytic fission. Let's see the matter. An organic compound methyl chloride. Here, this carbon-chlorine bond is a kind of covalent bond. Again, it's a polar bond because electronegativity of chlorine is 3.0 and electronegativity of carbon is 2.5. That is why this carbon-chlorine bond becomes polar. We know this bond, covalent bond, has 2 electrons. This covalent bond is formed by 2 electrons, and this carbon-chlorine bond is a kind of polar bond. When this compound is heated at low temperature in presence of polar solvent, then this carbon-chlorine bond in presence of polar solvent breaks in this way. That is, 2 electrons of this bond move towards this chlorine, which is higher electronegative element than carbon, and this arrow is known as curly arrow, which means movement of 2 electrons. This is called curly arrow or double-headed arrow. In presence of polar solvent and at low temperature, this bond breaks in this way. Carbon cation is formed and chloride ion is formed, which is known as methyl carbocation. It is formed when these 2 electrons move towards highly electronegative atom chlorine. This kind of breaking of covalent bond is known as heterolytic fission or heterolytic cleavage, and this phenomenon is known as heterolysis. As a result of heterolysis, 2 ions are formed, cation and anion. This cation with carbon positive charge is known as carbocation, which was formerly known as carbonium ion. Here we got methyl carbocation or methyl carbonium ion. Again, another compound, this is ethyl chloride. When ethyl chloride is treated with low temperature in presence of polar solvent, then this carbon-chlorine bond undergoes a heterolytic fission. As a result, these are formed. Ethyl carbocation and chloride ion. Here, this is ethyl carbocation, in which we see that carbon with positive charge is attached to only one carbon. That is why it's a kind of 1 degree carbocation or primary carbocation. Again, let us take another organic compound, hydrogen, carbon, here methyl group, chlorine. This is isopropyl chloride or 2-chloropropane. When this compound is treated in presence of polar solvent at low temperature, then this carbon chlorine bond undergoes heterolysis. As a result, this cation is formed. And chloride ion is formed, a kind of cation, carbocation, which is called isopropyl cation. This is isopropyl chloride and this cation is isopropyl cation. Here we see that carbon with positive charge is linked up with two carbon atoms. That is why this is called 2-degree carbocation or secondary carbocation. We got methyl carbocation, 1-degree carbocation, 2-degree carbocation. Again, another compound, this one. This is tertiary butyl chloride or 1, 2, 3, 2-chloro, 2-methyl propane. When this is heated at low temperature in presence of polar solvent, then this carbon chlorine bond experiences heterolytic fission. As a result, these ions are formed. Carbocation and chloride ion. This carbocation is called tertiary butyl carbocation, in which carbon with positive charge is attached to 3 carbon atoms. That is why it's a kind of 3-degree carbocation or tertiary carbocation. So we got 3 types of carbocations: 1-degree or primary carbocation, 2-degree or secondary carbocation, and finally 3-degree or tertiary carbocation. Another carbocation we got, that is methyl carbocation. This is all about heterolytic fission and types of carbocations: 1-degree, 2-degree and 3-degree carbocations. No more today. Thank you very much.